And 3D seismic is definitely not small. So here we can see, as we slice through the sin wave output, you can see how the amplitudes change when you drag this thing around. You can do all sorts of stuff here, flipping it around. It's just, I mean, you could play with that for weeks. so I won't. I'll just introduce my AV2 there. So back to the presentation. I mean, there were so many things I thought of, but didn't really have time to implement. So, the first one obviously would be rapid prototyping of seismic processing algorithms. Whether you want to work on a trace by trace or an entire gather or an entire stack section. That's quite easy in Run Python. Running up Google Earth files, it'd be great. You could have your 3D section right in Google Earth directly from Claritas. I think that'd be interesting. GIS type formats like GeoTIFFs, shape files, all sorts of other ones. Quite useful. Reading and writing custom or unsupported formats like HDF5, which is a format for hierarchical data storage. NetCDF is very similar. Any sort of custom ASCII, Python is fantastic, XML, etc. Sage is something I don't have time to go into, but it's a fantastic project for, again, scientific Python, and brings together a lot of these technologies we're using. And it has a web interface, so theoretically you could instantaneously have your results from your processing up and available on a web page. And you could interact with it through Python commands. You could write out Blender files if you wanted really high quality 3D rendering of the data. Christoph has used it a lot, so he'd be all over that. Any sort of custom action at the end or start of a script, you could definitely do. Okay, rocks. What do I need to use it? Okay, so Claritas uses the RPM packaging format under Fedora and Red Hat Enterprise Linux. It uses the .deb format under Debian and Ubuntu. And these things are fantastic. We just started using them in the last sort of year or so. And they do a great job managing the dependencies, which means if you're running a new system, basically you just install it with these things, and all your dependencies are there. It should just work. You just have to install your license key. That's it. So, that was my next point. Getting NumPy installed on some of these older platforms is a bit more work because it's not in the standard repositories. Getting it working on Solaris is a real pain, but it can be done. What about performance? But I love Fortran. Okay, so we measured the overhead of a job that created a lot of seismic data, and on one hand it did nothing with that data, and on the other hand it ran it through Run Python. And what we see is that it's less than a quarter of the overhead of an AGC filter, which is a very, very fast filter, automatic gain control. So being less than a quarter the overhead of that means you probably wouldn't notice this in a typical job. So, and that's what I've seen with some of the work I've done on it. So it's not really that big of a deal. And one of the nice things for performance is that we're sharing memory, so there's a constant overhead. Whether you're working on really large sections or very small ones, it's a constant overhead, and there's no copying. And the RAM overhead is fairly small. So if you do have a performance problem, what do? Well, what you should do is write the code at a high level. So using high level abstractions, high level languages, and then optimize the bottlenecks. Well, where are the bottlenecks? Well, you have to profile to identify where they are, and then focus on your algorithm, get that working as fast as you can. With both NumPy and MATLAB, you want to use matrix operations as much as possible instead of for loops and things like that. If it's still not quick, you can use other technologies like Weave. It's either Cython or Cython, I'm not sure, or F2Pi. I underlined Cython here, or Cython, because it's the one I would recommend. It's basically still Python, except it adds C-style types, so integers, floating point, arrays, structures, things like that. And that can speed up your code a couple orders of magnitude. So it's a really good cross between compiled languages and sort of dynamic languages. And if that's still not quick enough for you, Claritas works with MPI, so you can run it on a cluster. And run Python also works quite well with MPI, or at least it did for my test. So you could run it on a cluster and get the typical sort of speed up you would expect. But it's still not quick enough. So you must have a real performance issue there. So if it's CPU bound, computation bound, one thing you can look at is GPU processing, which is fairly new. And there's two sort of technologies that stand out to me. You have PyCUDA, which uses NVIDIA's CUDA architecture and tools to run on the GPU. This runs what's essentially C code on your GPU and gives you all the cores of your GPU and all that really high performance memory bandwidth on there. Depending on the problem, it can be very, very quick. Now, OpenCL is, as the name would suggest, an open standard sort of competing with CUDA. It was brought up by Apple, I think it was last year. It just got standardized. It's run by the same committee that runs OpenGL, so it's going to be there for a while. It's much harder to program in, but being able to run on anything like a GPU, CPU, these cell stream processors, that's going to be very, very powerful in the future. Being new, it's still very immature, and it's really only supported by NVIDIA and quite recently by ATI/AMD. So you can get a potential speed up of 500 times or more. Some of these algorithms, they'll show a speed up of 3,000 times. Now you got to wonder about that, but I took a course on this in Canada, and they suggested that the typical speed up was between 3 and 10 times. So, but some programs you'll see a speed up of 30 times compared to highly optimized C code. So that level of speed up is definitely worth it, but it's a lot of work, so it's not for the faint of heart. So here's a few resources I've listed, basically just websites and books. That's where I would go if I was looking to get started with Python and NumPy. SciPy.org and NumPy.scipy.org are probably the best one. They have some excellent cookbook examples, tutorials, some excellent webinars, a good wiki. The NumPy mailing list is incredible. I've asked a few questions there and had some great responses. And of course, in Claritas, we have example jobs under the examples directory, and they just give you a quick sort of demonstration with lots of comments on how to get started. So what's future work? Well, we currently support Python 2.x, but Python 3 has been out for a little bit now, and NumPy just recently supported Python 3. So at some point, we're going to have to support that. It's going to be a little bit of work, but hopefully not too much. We hope to support 3D arrays from C, because right now it's just 2D arrays. But if we could buffer 3D arrays, it'd be even better. We're planning on getting online examples, tutorials, movies, etc. Discussion forums would be great. We could post up some of our examples, like some of the ones you've seen here. I plan to have a zip or tar.gz file of these, so people can experiment with them on their own. And the last thing would be the ability to call a Python class instead of just a function. And that's just it's fairly obvious how to do that, so it shouldn't be too hard. All right, any questions? Any?
Could you show us the code that you used for saving